Future value. The future value of an investment, A, when the principal P is invested at an annual interest rate of R, compounded n times per year for t years, can be found using a formula, but we are going to use a TVM solver that uses the formula instead. Example, compounded future value number 1. Compute the future value of the investment with the given conditions. Write the values in the TVM table below and use the TVM solver to calculate the missing value. Principal is $5,000. Annual interest rate is 3.8%, compounded monthly, for 5 years. How much will be in the account at the end of 5 years? So looking at our table, the first value we need to complete is capital N. Well, this is the total number of compoundings, total number of times that we are compounding. Because we are compounding monthly, that's 12 times a year, for 5 years, we need to multiply 12 times 5 to get 60 for our capital N. I, as a percent, is given to us as 3.8%, so we will type 3.8 in that space. For present value, we have our principal. We currently have $5,000 in the account. That's present value. The payment is 0 because that would be a regular payment that we're adding to the balance. And there isn't anything here for all the questions we have in this section. That'll be the case. We'll have a payment of 0. The future value is what we're interested in, so we'll leave that one blank for now. P/Y, payments per year, well, we just said it was monthly, so we'll select 12 from the options of 1, 2, 4, 12, 52, and 365. Those represent annual, semi-annually, quarterly, monthly, weekly, and daily. Compounding per year will also be 12. And at this point, it does not matter whether we choose beginning or end for these questions, so I will just default to using end. So now let me pull up my TVM solver and input those values. N equals 60, I equals 3.8, present value equals 5,000, payment equals 0, future value, I'll leave blank. P/Y, payments per year, and C/Y, compounding periods per year, will both be 12. And we'll leave this at end. And then finally, we will click solve on the blank labeled future value. The value that's here is negative 6,044.43. We chose the solve. I'm going to go ahead and circle solve under future value. So the resulting amount is negative $6,044.43, which means the future value in this account is $6,044.43. Now this question doesn't ask for this, but sometimes we are interested in how much interest we accrued. So we know our $5,000 is now worth just over $6,000, but how much of that was interest? So interest earned would be our future value minus our principal, which is our present value. So $6,044.43 minus $5,000 means that the earned interest is $1,044.43. Example, simple versus compound interest. Compute the future value of the investment with the given conditions with only simple interest. Principal being $5,000, simple interest rate of 3.8% for 5 years. How much will be in the account at the end of 5 years? Well, our future value of a simple interest formula was A equals P parentheses 1 plus RT, or just principal plus principal times rate times time. So if we I'll use the second formula, but if we calculate that, that is principal is 5,000, so 5,000 plus 5,000 parentheses 0.038 close parentheses, open parentheses, 5. 5,000 plus 5,000 parentheses 0.038 close parentheses, open parentheses, 5 close parentheses. This is $5,950. So now, of course, our question is compare this simple interest calculation, same interest rate, same amount of time, with the compound interest. Well, very clearly, compound interest resulted in much more money. Approximately, well, I say much more, less than $100 more, but there is a difference. The point is compound interest gains interest on your interest as well as interest on your principal. Therefore, compound interest is the better choice if you are trying to save, but simple interest is better if you are borrowing money. You want the interest to be low when you're borrowing money, but you want it to be high when you are earning money. Example, compounded future value number 2. Joe invests $3,000 for 15 years at 4.3%. How much will he have in the account at the end of 15 years if this is compounded monthly? What if it was compounded semi-annually? Well, let's fill in our time value of money. First, for considering that it's monthly. So capital N for monthly would be 12 times 15. Compounded 12 times per year, monthly, for 15 years. 12 times 15 is 180. So N equals 180. I as a percent would be 4.3. Present value would be $3,000, the initial investment. Payment is 0 because we are not adding to the balance periodically. Future value, we would like to know, and we will choose solve for that, so I'll go ahead and circle solve on future value. Now payments per year and compounding per year would both be 12 because we're talking monthly. And then finally I will choose end under payment because it doesn't actually matter. It does matter with problems we'll run into later. And so I will pull up my TVM solver and replace those values. So N equals 180. I percent is 4.3. Present value is 3,000. Oh, present value is wrong blank. Present value is 3,000. Payment is 0. Future value is blank. Payments per year, compounding per year, both 12 and N, so I will click solve on future value. And that is negative 5,711 and 37 cents. And so we have a future value, if this is compounded monthly, of positive $5,711.37. Now let's consider what would happen if we change this to semi-annually. I'm going to add these values over to the left actually. So for semi-annually, N will instead be 2 times 15, twice a year semi-annually, which is 30. I as a percent would still be 4.3. Present value would still be 3,000. Payment would still be 0. We still need to know future value. Payments per year and compounding per year both be 2 for semi-annually. And we would leave payment, since there isn't a payment, at end. So if I go back to my TVM solver, replace those values, N equals 30, I is 4.3, present value is 3,000, payment is 0, future value is blank, P/Y, C/Y are both 2, and leave it at end. I'll click solve on future value and find that I have the value negative $5,679. .01. So that we have a positive $5,679.01 if we are compounding semi-annually as opposed to monthly. So looking at this, the more times we compound each year, the better it is for the bottom line, for what we actually earn out of this. But again, if we are borrowing money, we would want something that compounds less frequently, not more.